Kerosene is one of the most versatile fuels derived from crude oil, and its story is deeply connected to the development of modern society. Before it powered jet engines, it was the world's primary source of light, replacing whale oil and making evenings safer and more productive. This humble fuel was a cornerstone of the industrial age. To understand what kerosene is, we first need to look at its origin: crude oil. This fossil fuel is a complex cocktail of hydrocarbons formed over millions of years from ancient organic matter trapped deep beneath the Earth's surface. Once extracted, the crude oil is transported to a refinery for a process called fractional distillation. Inside a massive distillation tower, the oil is heated to extreme temperatures, causing it to vaporize. As this hot vapor rises through the column, it begins to cool. Different hydrocarbon chains condense back into liquid at different levels, separated precisely according to their unique boiling points. Lighter fractions with lower boiling points like gasoline rise to the very top. Heavier ones like diesel and lubricating oils condense much lower down. Kerosene is collected from the middle range, typically distilling between 150 and 275 degrees Celsius. This strategic position makes it less volatile than gasoline, but lighter and cleaner burning than diesel. This specific distillation range gives kerosene its valuable balance of stability, high energy density, and relative safety, making it ideal for both storage and transport. Chemically, kerosene is a mixture of hydrocarbons with carbon chains containing 10 to 16 atoms. This molecular structure is the key to its performance, allowing it to burn with a steady flame while providing significant energy. The history of kerosene is a fascinating tale of innovation, illustrating how a single energy source can reshape human progress. Before electricity, the world was largely dictated by the sun. Kerosene was the revolutionary fuel that first conquered the night, illuminating millions of homes across the globe with a brighter, more consistent light. The transition was critical. By the mid-19th century, whale oil, the primary lamp fuel, had become prohibitively expensive due to overhunting. Kerosene's arrival provided a lifeline. It was a significantly cheaper, more accessible source of light that also dramatically reduced the immense pressure on whale populations, a pivotal moment for both society and nature. Kerosene lamps quickly became symbols of modernity, extending the day for work, study, and leisure. This newfound light was also instrumental during the Industrial Revolution. Its affordability illuminated factories for longer, more productive shifts, which in turn fueled economic growth and improved the overall quality of life for many. And while electricity eventually superseded kerosene in most developed regions, its story didn't end there. To this day, it remains an essential energy source in many rural and developing nations. In places where electrical grids are unreliable or non-existent, these simple lamps continue to provide a vital source of light, proving its enduring relevance in the modern world. The importance of kerosene goes far beyond lighting. One of its most critical roles today is in aviation. When refined to aviation standards, kerosene becomes what is known as jet fuel, specifically Jet A or Jet A1. This fuel is ideal for jet engines because it combines high energy density, clean combustion, and relatively low freezing points, which are crucial for flights at high altitudes. Without kerosene-based jet fuel, modern air travel as we know it would not be possible. Every commercial airliner from small passenger jets to massive long-haul aircraft relies on kerosene to operate efficiently and safely. Military aviation also depends heavily on kerosene-based fuels, making it a strategic resource for national defense around the world. Beyond the world of aviation, kerosene's story continues on the ground, where it remains an essential fuel for both households and industries across the globe. In vast regions of Asia, Africa, and South America, kerosene is the lifeblood of daily existence. For millions in rural communities without access to natural gas or a stable electrical grid, it is the primary fuel for cooking and heating. Kerosene stoves and heaters are relatively inexpensive, simple to operate, and highly reliable. This practicality makes them a mainstay where modern infrastructure is limited, providing crucial energy security. Kerosene lamps also illuminate homes, allowing children to study after sunset and extending the productive day in the absence of electric light. Even in developed nations, portable kerosene heaters are a popular backup source of warmth, providing a safety net during power outages from winter storms. For many families, kerosene is not just an option but a necessity that ensures survival during harsh winters. Industrially, kerosene's chemical properties unlock a different set of powerful applications. As a solvent, its ability to dissolve oils and greases makes it ideal for degreasing heavy machinery and cleaning metal parts. In agriculture, it acts as a carrier liquid for certain pesticides, ensuring the even distribution of active ingredients. It is also a key feedstock for producing paraffin wax, used in everything from candles and crayons to protective food packaging. But its most dramatic role is in space exploration, where a highly refined version is instrumental. This fuel, known as RP-1, is a purified kerosene with the ideal density for powerful rocket engines. It famously powered the first stage of the Saturn V, which carried astronauts to the moon. Its use continues today with modern rockets like SpaceX's Falcon 9 still relying on RP-1 as a cost-effective and powerful propellant. From a simple lamp to a rocket engine, this journey demonstrates kerosene's incredible versatility and its lasting impact on human technology. However, the use of kerosene also comes with challenges and concerns. One major issue is related to health and environmental impact. When burned indoors, particularly in poorly ventilated areas, kerosene can produce harmful fumes and particulate matter that may cause respiratory problems. In developing regions where kerosene lamps and stoves are widely used, long-term exposure to smoke and emissions is a serious health concern. Environmentally, while kerosene burns cleaner than coal or wood, it still contributes to carbon dioxide emissions, which drive climate change. For this reason, many governments and organizations are encouraging a gradual shift away from kerosene toward cleaner, renewable energy sources such as solar and wind power. Nevertheless, the transition is complex, since kerosene remains affordable, portable, and easy to store compared to many alternatives. Another important aspect of kerosene is its role in emergencies and humanitarian aid. Because it is stable, easy to transport, and does not require complicated infrastructure, kerosene is often distributed as emergency fuel in disaster-stricken areas. When natural disasters such as earthquakes, hurricanes, or floods cut off electricity and gas supplies, kerosene stoves and lamps provide families with essential cooking and lighting options. Aid organizations frequently rely on kerosene because of its reliability in these situations. Its importance in humanitarian work highlights its enduring value in a world where access to modern energy is not always guaranteed. Looking to the future, the role of kerosene may change, but is unlikely to disappear entirely anytime soon. In aviation, researchers are exploring biofuels and synthetic fuels as alternatives to traditional kerosene-based jet fuel, aiming to reduce the carbon footprint of the airline industry. However, these alternatives are still in development and face challenges of scale and cost. Until they become widely available, kerosene will remain the backbone of global air transportation. In households, solar lanterns and electric stoves are gradually replacing kerosene, especially in regions where renewable technologies are being promoted. Still, kerosene will continue to be important in areas where infrastructure remains underdeveloped. Its legacy as a transitional fuel, bridging the gap between traditional and modern energy, will likely persist for decades. In summary, kerosene is much more than just another petroleum product. It is a fuel that has shaped human history, from lighting homes in the 19th century to powering airplanes and even rockets in the modern era. Formed through the careful distillation of crude oil, it combines energy density, stability, and versatility in ways that few other fuels can match. While its use for lighting has declined with the spread of electricity, its importance in aviation, industry, and household energy remains undeniable. At the same time, its environmental impact reminds us of the need to balance energy demands with sustainability. Whether as a symbol of industrial progress in the past, or as a crucial link in today's energy chain, kerosene stands as one of the fuels that truly powered the modern world.